First step in implementing the inferential procedure is to check the assumption. And the very first and the basic assumption of any inferential procedure is to check the normality of the data. Normality of the data is not only to be checked for the procedure, but it is used for finding the outliers in the data as well. So there are the two purposes of testing the normality of the data. The first thing is to check whether the data follows normal distribution or not. And the second important thing is there any outlier in the data that can be detected through the normality? And testing normality or checking normality? Because checking normality, because sometimes we need to use graphs for checking normality, or we have a test, specific test, inferential test for checking normality. I will cover these two procedures here. Normality can be checked by making histogram or stem and leaf, by box plot. If the box is in center, then we can assume the data is normally distributed. If we have a histogram which is bell shaped, like height 1, height 2, height 3, height 4, and so on, if this is the case, then we can call the data is normally distributed. If your stem and leaf is like this, 1, 2, 3, 4, 5, and here you have 1, 1, 1, 2, 5, 1, 3, 5, 7, 9. Then again we have 2, 7, 1, 8, 3. If the stem and leaf is like this, so you can assume the data is symmetrical or approximately normal. Box is in center means your box, the left whisker is equal to the right whisker, and the median is in center. We can call the data is normally distributed. So these are basically the diagrammatic procedures to assess the normality of the data. Normal probability graph is a new thing because it is first time we are going to consider how to check the normality by the normal probability graph. Now we can, in SPSS we call it as a PP plot or the QQ plot. PP plot is, or the QQ plot, it is for testing or assessing the normality. If the normal probability plot is linear in shape, we can call the data is normal. So in the normal probability plot, your points are more or less linear in pattern. If the points are in linear pattern, we call the data is normally distributed. If the points are on a curve, we cannot say the data is normally distributed or not, right? Another way of assessing the normality is by test. This is the formal procedure of testing the normality. Two tests are very important in statistics. One of them is known as Kolmogorov-Smirnov test. Second test is called Shapiro test. These two tests, we will not consider manually implementation of these two tests, but we will cover these two tests in SPSS. Now this is the data. One example I'm going to consider for assessing the normality. This is the data, and we have a large sample size here, but we want to check the normality. Actual question is to find the 95% confidence interval of mean, but I want to express how the normality of this data is checked. So these are the 4 different graphs from this data. This graph is known as a probability plot. Normal probability plot is in A. If it is linear, we can call it as normal. If the histogram is in bell shape, we can say it is approximately normal. If the box is in center and the median is in center, we can call it as normal. And if the normal probability plot is in this shape, we can call it as normal. So in this case, we have the two outliers. After eliminating these two outliers, we can construct this graph again so that the normality of the data can be checked. Now I'm going to implement these four graphs into SPSS, how these four graphs are to be constructed in SPSS. Um, then we will cover the testing of normality by Kolmogorov and Smirnov test in SPSS for the same data set. The first thing, we have to get the data from this table. This table is in the picture form. I cannot get the data copy and paste from this table to the SPSS. So I am moving to the book, which is the book is in the PDF version. The same problem I will consider in the book, and then from that book I will take the data copy from that book and taken to the SPSS. Or if it is not directly comes into the SPSS, then there is a possibility that we will switch this data to the Excel first, and then from Excel to move into the SPSS. So these are the few steps that are needed to complete the normality of the data. How to reach the same problem into the book? You can see here in search button in PDF, you have to uh, write down the text civilian labor force. Search this into the PDF. You will be there, civilian labor force. This is the same problem as we have in the presentation. This is one mean Z interval procedure. So we are going to test the normality of this data first before implementing confidence interval procedure. Just copy the data from here and then paste this data into the Excel. Now Excel, I am going to paste the data here. Entire data is pasted here, but you can see this data is in the text format, not in the number format. So we have to convert this data into the number format. How we can convert? Just go to the data tab and text to column. Text to column is a option that is used to convert the text into numbers, and this text is to be splitted into the different columns. So now click this delimited or the fixed length. My data is a fixed length data because every number based on 2 digits. So I can use fixed width. You can see if I use finish button here, then evenly this data will be converted into the Excel columns. Now data comes into the Excel column, but we need all the data into one column, not in 4 different columns, because SPSS recognize this as a one column data. So I am just placing this data from here into one column. You can see the process of making the data into one column. Now the last is this. Now the entire data is in one column. I can take this data from here and place it into the SPSS. So I'm switching to the SPSS and pasting the data over there in SPSS. Now this is SPSS. Now the name of the variable is var00001. I want to change the name of this variable. I want to keep the name of the variable as X. And one more thing which is very important here, because this is a numeric variable, we have to change the measurement scale. Measurement scale will be scale in this case because the pure quantitative variable. If the decimal places are there, you can keep the decimal places as 2. If there is no decimal place, you can keep decimal place to the 0 so that the data becomes in whole numbers. Now your data is in whole numbers, and I want to cover all those things here. Go to the analyze, descriptive, and in explore, as I told you, in explore we have explore is for used for the quantitative variable. The explore, and my variable is x, dependent variable is x. There is no factor variable. In statistics we have a descriptive measures, as well as if you want to find out the percentile, you want to eliminate the outlier. Confidence interval of mean, it is the interval estimation. It automatically be calculated for this variable. Now continue in the plot segment. If you need both histogram and stem and leaf, just click on the both. If you need only one, you can this is very important. This is what normality plot with test. It will implements two things. Now I'm just zooming it. It is very important. It is. You can see it clearly. Normality plot with test. What this does? This does normality probability plot. Normal probability plot will be constructed, as well as Kolmogorov test and Shapiro test will also be implemented by using this. So these are the four things. One is stem and leaf, other is histogram, normality plot, third thing. And the fourth thing is testing the normality by Kolmogorov Smirnov test and Shapiro test. So I'm going to continue and okay. Now I am showing the SPSS output. In this output, you can see in this output, you can see the first table, 50 observations of one variable. The name of the variable is X, and no missing number is there. 50, all the 100% data we have. These are the descriptive measure. I already covered the descriptive measure in the earlier lecture. The sample mean of this variable is 36, and 33 is confidence interval. Confidence interval is what? Confidence interval is basically we can write down the confidence interval here, mu from 33.23. This is the lower value of the confidence interval, 33.23, and up to what? And up to 39.53. 39.53. This is the confidence interval. That is actually the objective of this chapter. Obtain a confidence interval for population mean. So this is the sample mean, and this is the population mean. This is the interval estimate of the population mean. Further things are here. We have a 5% tree mean. All of these things are already described, but I am going to consider the two test here. Before going to implement the two test, I want to explain the graphs of normality. The graph of normality are where you can see the histogram. There is slightly skewness because if we are constructing like this, it will be normal, but it is slightly positive skewed. Mean and standard deviation of samples are here. And this is stem and leaf, and you can see that it is again right, slightly right skewed. This is probability plot. As I told you, in the probability plot, QQ plot, normal probability plot. If this line is a straight line, if these dots will be on the straight line, I can say that the data is perfectly normal. But if these are the deviations from the straight line, so I can say that it is not perfectly normal, or neither it is normal. So by conclusion, we can see here data is right skewed, as well as you can see skewness here. It is 0.77, it is 0.55 skewness and kurtosis. As I told you, if it is normal, then 0 should be there. This table, I will describe this table in detail because these are the two tests, Kolmogorov and Shapiro test. I will describe it in detail, but by graph, my conclusion is this is not normal, or we have a slight deviation from normality. This is again showing a right skewed. This is again showing a right skewed. This is zero point 0.7 skewness is showing right skewed, and kurtosis is 0.5. If kurtosis is 0, then we have a mesokurtic. It is 0.5. It means we have a slightly higher than the normal distribution. Now, lastly, I will describe Kolmogorov test in detail. This test, these are the two tests. One is called, this is the output of the first test known as Kolmogorov Smirnov test. This is the output of another test. This is known as Shapiro test. There is a possibility that both of the tests will not be will give you the same result. There is a possibility that these two tests will give you a different result. There is a hypothesis behind this test because every statistical test have a hypothesis. In this case, the hypothesis is data is normally distributed. Data normally distributed. Data is normal. This is null hypothesis. Data is normal. And in the alternate hypothesis is data is non-normal. H1. H1 is the alternate hypothesis. Data is non-normal, not normal. So your assumption is data should be normal. So if your null hypothesis is true, then you can say that we can apply the inferential procedure. If this is the formal test. We have to compare these two numbers. These are the very important numbers. These are sig. Only one thing is important here for both of the tests, that is the value sig. If your value of sig is larger than 0.05, 0.05 is the level of significance. If these numbers are more than 0.05, the null hypothesis is true. If these numbers are less than 0.2, according to the Kolmogorov test, data is normally distributed because 0.09 is larger than 0.05 and 0.03 is smaller than 0.05. According to the Shapiro test, at 5% level of significance, the data is not normal, but according to the Kolmogorov test, the data is normally distributed. According to the Kolmogorov test, I can accept the null hypothesis because it is more than 0.05. So if null hypothesis, if p-value, this is called p-value. Very important thing. Sig value is what? Sig value is the significant value. And in statistics, the sig value is known as p-value. So if p-value is if p-value is less than or equal to 0.05, we'll reject the null hypothesis. If p-value is greater than 0.05, if we are testing at the 5% level of significance, then H0 will be true. If we can change the value of alpha. This is 0.05. We may have at 0.01. If we are testing at 0.01, we compare these two p-values with the 0.01, and at 0.01, the both tests are saying that the data is normally distributed. So in conclusion, I can say that the tables are giving us a concept of slightly skewness. We have a slight skewness here. because it is not zero. It is not zero. We have a slight right skewed. But these two tests, in the first test, Kolmogorov test is saying that the data is normally distributed. Shapiro test is saying that at 5% level of significance, data is not normal. But if we are testing it at 1% level of significance, we can say that the data is normal. The graphs are saying that the data is slightly right skewed. These graphs are slightly right skewed. If these points are on the line, then we can say that it is normal, but it is slightly deviated. We can say that it is a slightly deviated from the normality. So in conclusion, I can say we can apply the confidence interval procedure because most of the things are closer to the normal distribution. One of the very important thing which is found in the assumption of procedure, and that thing is what? That thing is, I am looking the assumption again here. I am showing you the slide where these assumptions are here. You can see here the assumptions, and you can see the assumptions here. According to the assumption, either the population is normal or the large sample size. Still, if someone is making the decision that the data is not normal, but still we can use the Z procedure or central limit theorem, because in this example, the data size or the sample size is of 36, which is large. So we can say that I can use the procedure of confidence interval for finding the mean by using the Z test that can be implemented, because in the Kolmogorov Smirnov test is saying that the data is normal. Large sample size is also identifying that we can use this procedure even if the data is not normal. We can apply that.